time for another class
I
session.
feel like McDonald's.
This right here is, we're talking about a heater chase, chasing a heater. If you missed the PowerPoint yesterday, you need to watch it on YouTube because it's on there. Some really good stuff on that one. The guys that were here, what do you think? Was that a good one yesterday?
That was good.
Yeah, you all really excited about that one.
Dude,
This is
about
the
lost
heater
his
chase
eyeball.
war story. That's the service bay where I used to work a long time ago. And, but everybody that's ever done much of anything has replaced at least one or two oxygen sensors if you've worked on cars enough to do all that. And what we used to see long years ago was we would see them go driving down the road and they would flatline and then they would come back to life. And it was a crazy thing. And they used to have this lean cruise mode on some of the Ford pickup trucks. It was really strange where when you were driving down the road, if you happened to be looking at your data stream, you would see it go into lean cruise mode. It would bottom out. The oxygen sensor would while you're driving down the road, but it was a strategy and there was no codes thrown or anything. But there was this one guy that came in one day on this 92 or 93 F-150 and he said, every now and then I'm driving down the road and it'll feel like somebody ran into the back of the truck. And so I put the portable vehicle analyzer on it with the SBDS machine and I drove it and we got it to do that. When I was driving along cruising, I'd come over a hill, I would feather the throttle just right and it would literally feel like somebody ran into the back of the car like they do on them crazy movies where somebody runs into the back of a car, which I always thought kind of dumb, you know, what you gonna do? Bam, you're in the back of somebody's car. So anyway, I went back and I uploaded that file because it had actually come out of that open loop lean cruise mode and operated the EGR for a second for some strange reason. And the guys up there at Ford, whenever he called me back, he says, you'll never fix that because that's a strategy designed in there and there's not enough people complaining about it where we're going to do anything about it, which I thought was strange. But these little suckers here, when you're driving along, if the oxygen sensor is lying to it and telling it it's lean, when it's actually not lean, it can make it puff out black smoke, run rich, and all kinds of things. All right. Now, since most multi-bank platforms have the O2 sniffing the exhaust for each bank for about 10 years or more longer than that, actually, we use the O2 for a tool while we're chasing misfires. The engine controller will use it for a tool. When it's in a self-test situation, it will actually start delivering upstream air and look to see if the oxygen sensor is recording air going in there. So it's a handy little tool to have down in there. Now you can actually use it for that. Now the fuel trim numbers are a spin-off of this really useful signal. Whenever you got a healthy oxygen sensor, it's supposed to be switching up and down like that right there. And it'll usually switch faster when the engine's running faster than it will when it's idling. But if it's doing like it's supposed to, you ought to see a camera hump looking like that right there. If it goes down here, it's lean. If it stays up there, it's showing rich. And it's going to try to correct in the opposite direction. If you're watching the fuel trim on another screen, when this goes up, fuel trim will go down to try to pull it back to the center. And this is kind of what it looks like on the Genesis scan tool. Notice you in closed loop fuel control. You got short fuel trim, bank 1, 25%. And then you got bank 1 sensor 2 at 0.4 of a volt. And bank 1 sensor 1, you got 25. So that's the short fuel trim and long fuel trim. See, long fuel trim right now is at 0. What's that telling us? That's telling us that whatever is causing these things to do this has just happened because long fuel trim hasn't responded yet. It'll start walking up and short fuel trim will eventually come back to 0. Now you got to understand the signal. The cycle frequency should be a maximum of 1 second on that. If you see an oxygen sensor that's sluggish, a lot of your PCMs now will throw a code that'll say oxygen sensor, HO2 sensor 1 or whatever will be sluggish or is slow or slow response or something like that. Each time the voltage line crosses the 0.45, that's a cross count. So the number of cross counts in a given amount of time is what you're looking for because that's giving you how fast that signal's switching. See? All right, so the lambda sensor, they called it a lambda sensor when it first came out in 1975. They started putting it on Saabs, I think, or Volvos or something. And it was quite a few years, it was a one-wire sensor, like this right here. It's wired up like that. This was your ground, and you had one wire coming out. It depended on the exhaust to get this hot, and that signal right there, that went to the computer. There was a Chrysler one time I was working on, it was running rich, and I suspected the oxygen sensor, and I remembered something that Ellen Smith told me in Houston, back whenever most everything had one-wire sensors on it. I says, what you're going to do is touch the battery terminal and go to the wire that's leading from the oxygen sensor to the engine controller and just, tap it with your fingers like that, and if that black smoke clears up, you got a dead oxygen sensor. Later on, I got the back probe in it and I'd watch it. So I always wanted to know if the oxygen sensor is reading the lean, is it telling the truth or is it telling a lie? And that's basically what that. When you get a new oxygen sensor too, most of us know you'll have a little bit of anti-seize compound like you see on these threads right here. All right, so, come on. This is the chemically perfect ratio. That's what lambda is for air for complete burn. No matter what the fuel being used. Just about all late model vehicles have a lambda PID, and it's like 1.0 if it's perfect burn. Lambda is a scale that relates air to the fuel of any fuel. 1.0 is a perfect balance. Less than 1.0 indicates a rich mixture. More than 1.0 indicates a lean mixture. If you're, in other words, that's the direction you're looking. So stoichiometry, which is the cleanest mix, is different for every fuel. Some of them, gasoline is 14.7 to 1, but it's different for alcohol fuel and stuff like that. You know, some of them can go as low as 6 pounds of air for a complete burn. But the stoichiometry is, how clean is my burn? That's what it's looking at. An oxygen sensor can tell it that. Whenever you're looking at desired lambda, see, if you got long-term fuel trim plus or minus 5%, you got no fault there, and you don't have to put any possible causes because there's not a problem there. And then you got, this one here is plus 25%, but the actual air-fuel ratio is 1.0. The unmetered air leak, you got a stuck closed injector. If the air fuel or O2 sensor is working right, lambda can be maintained. On that green GMC, it's got an injector, it's not delivering any fuel, and you're going to have a reading like that looks like that. And then finally, if you're looking at your desired lambda being 1.0, the scan tool works in that. It works at a desired target and what it actually is. And if those get too far out of line with one another, it indicates a problem. So you need to look at your desired target and where it actually is if you're looking for trouble. So 0.75, you got this, if it's gone far enough, you know, to where it's actually at plus 25, sometimes it'll go higher than that, you know, on some platforms. Then you're going to see that low. If you see this low, that means it's basically, you know, got bad data, the PCM's adding fuel, this kind of thing. All right, so since the emissions folks wanted the O2 signal to be cleaner, they put a ground wire on some sensors and made them 2-wire sensors, and that's what one looks like. They still relied on exhaust heat to raise the ceramic thimble in that little thing to 600 degrees. So this is how it was wired up. You basically had your ground, which was a dedicated ground, and instead of depending on the threads for the ground, it had dedicated ground, and then you'd have a signal out on that one there. That's what the wiring schematic looked like. Then you come to 3-wire sensor. That they added a heater and a fused ignition feed that went to the sensor heater. It just went straight to it. See, so basically what you had here, you had a fuse going to that heater, and then it was hardwired to ground. Notice that? Fuse going to the heater, hardwired to ground, and basically you got the 3rd wire there, your signal going over there. And this was your O2, this was a ground reference that it used right there. But they decided that they wanted to do something else here. The ground reference was for the, you know, the signal. All right, so let me see if this will work right. All right, let me back up. I need to do that. I need to see if that'll come and show me. Let me just tell you this, because I don't think this older computer is going to show the PowerPoint. What they eventually wound up doing, instead of having that heater directly hardwired to ground, they ran it over here, and they made it the computer control the ground current to the O2 sensor. All right, it's a 4-wire sensor and a dedicated ground to clean up the signal, and the heater now had its own power feed dedicated ground circuit. And this may be what I was hoping to get. There it is, right there. I'm sorry. I thought it was on a previous slide. I've slept since I built this one. But anyway, this is kind of what it looks like in the schematic, and that's the sideways schematic of it. So basically, the heater is actually being controlled by the PCM. Let me back up so you can see the difference. See what they did? They put the heater in there. All right, and so you got basically the heat element was on there, and so the heater was basically powered up on some of them and grounded on others. So on this particular kind is different from the one we're going to be talking about today. But you get the idea. Some of them operate the ground, and some of them operate the power. But most all of them now that I know of fight the power. See the ground, the power's coming in here. That's actually going to other circuits in there. All right, the newest sensors are referred to as air-fuel ratio sensors, and they got more wires even yet. They got a heater, a signal wire, a signal ground. They got an additional circuit that pumps the signal up or down. Now you're going to see a beautiful little lesson on this in your electube. It's just absolutely gorgeous. It's going to show you the cutaway of that sensor, exactly how it works. You're going to learn all about that. I'm not going to spend a whole lot of time on this because of that reason. But you notice you got a whole bunch more wires coming to it. That's what it looks like on the wiring schematic. This is what the pinout's going to look like. You got a heck of a lot more wires going there. and there's your front of your sensor connector. The difference in a wideband and a narrowband sensor, the wideband was the one with all the wires, the extra wires. This is what the signal kind of looks like right here. There's your best power right here, right in that range right there. Okay, so basically you want the cleanest burn too. Your stoichiometry, you notice that your stoichiometry and your best power don't line up. Stoichiometry is the perfect burn, and basically whenever it's doing its switch, that's where it's at. This one right here, a wideband sensor's got a different kind of readings, you know, different voltage and everything else. All right, now, since the heater is totally controlled by the PCM, it's really interesting how some of the Chrysler applications I learned about when I was going to Chrysler school, that thing wakes up in the middle of the night and it shoots 5 volts out there and it powers up the O2 heater to see if that 5 volts will drop away as the resistance of the thing changes. It does it while you're sleeping. You don't even know what's happening. It just opens its eyes in the middle of the night and does that. Most of them are not quite as spooky as that. They're just continuously monitored by the PCM for a current draw. And then you got some of this. The older style sensors, you're going to see this unnecessary chart somebody put together for wire color. You notice the sensors have got a different color wire coming from the sensor to each per connector than it does coming from the harness. The 2 wires that are the same color are typically always the heater. They'll either be brown, black, or white. That's been my experience, if they're brown, black, or white. All right, so we're going to dive into an O2 heater concern. This is the war story portion of it. First and foremost, you got to know exactly which sensor the code's pointing at, so you don't do a lot of work on the wrong sensor. That happened to me in 1994 when this first came out on a Thunderbird I was working on. It was throwing me a code for a sensor, and I spent about an hour working on the wrong sensor because I wasn't sure what was 1, and 2, and all that kind of stuff. I didn't know how they had a number. But what you got to realize is bank 1 is always where sensor 1's going to be. All right, bank 1 on a Chevy and a Ford is on the opposite side, right? So you're basically going to be looking at bank 1, and sensor 1 is going to be on a different side of the engine than on Chevy. So don't get confused by that either. And make sure you know which bank is bank 1 because the number 1 cylinder will be there. That's how that is. Right here we got mill illuminated. It just came in for a check engine light. That's what this one was. Now this one gets pretty darn interesting. It belonged to the used car department. And the technician had jerked 2 lean codes and 3 oxygen sensor codes, all pointed at some sort of a weird O2 problem. You barely can read that. But basically we're seeing a heater 2-1 fault. See that? That's bank number 2, which is the bank on the driver's side, and it's the sensor in front of the catalytic converter. There was a fault there with a heater, HTR21F. That stands at heater, 2-1 fault. All right, I looked at the pitch, found the long fuel trim figures at plus 25 on each bank. The short fuel trim figures couldn't decide what to do when the engine was off idle. They were bouncing all over the place. And this failure flag was a big fat yes right there. Okay. One error came to pass when we got so caught up watching the fuel trim readings in the darkness of the check engine light. We cleared all of it. You just wanted to see if it'd come back. Since the mill was extinguished and the fuel trims looked good after we dumped the memory, we got back into it. We figured, well, we must have it fixed. But what we didn't realize was the exhaust heat right after we did that was keeping the sensor warm on the test drive, and the PCM didn't reflag the heater problem. I don't know what the criteria was for that, but it didn't happen. We should have pursued the fault we saw on the initial scan. So the mill came back on while the used car department guy was driving it for something else. So I brought it back in and I had 3 heater codes, PO135, PO141, PO155, PO171, and a PO174. And cool running oxygen sensors can flatline and throw lean codes. Incidentally, what I used to see sometimes, what do you do if you get one when you bring it in there and all the fuel trims look normal, all the oxygen sensors are working like they're supposed to, but it's got codes for rich and lean. In other words, it's got codes saying that it's rich and it's also lean. What do you think is going on there? What happened? No. I used to see it on ones that didn't even have a mass airflow. Nope. What happens on those, the oxygen sensor would belly out and it would jack the fuel trim way up. And then the oxygen sensor would come back online. And now when it's back online, the fuel trim's so doggone high that it's reading rich all the time. And it was in lean territory long enough to throw a lean code, and then it wound up in rich territory long enough to throw a rich code. Now, if you're not listening and not paying attention to this, you're just totally wasting your time and mine. So pay attention to what I'm saying. And I know you're sleepy and you'd like to take a nap and you're tuning me out and you're thinking about playing 8-ball pool and all that. Okay. Right here, we got use the homemade tool. get an old oxygen sensor connector. Anybody that's ever changed an oxygen sensor, you don't put that thing in the trash, clip the connector off of it and put it in a box somewhere, because you're gonna need it probably. I disconnected the O2 sensor, and I put a bulb hooked up to the two white heater wires, and installed the tool because the sensor was the most accessible there, you know, at 2.1. So the key switched on, the 12-volt bulb ought to light up. You should see that bulb light up if you got a bulb wired up into your two heater wires, and you're plugging a bulb in where your oxygen sensor ought to be. You crank it up, turn on the key, whatever, you ought to see that thing fire up. Even if, I don't know if anybody's ever had this before, but when you've got an engine switched on for a while, and you're sitting here watching it, and you're working under there, if the key's been turned on or if you've got to turn it off, you may even touch the oxygen sensor and find out it's really hot, even though the rest of the truck is cold. But that heater's like a cigarette lighter in there. All right. On Jeeps, the engine has to be started before the heater circuit will fire up. And since the PCM can opt not to energize the sensors on its own, I usually start the engine just to be sure, to make sure the light doesn't burn. Now, I also had a breakout harness that I put in there that I would go between the sensor and the engine wire harness, and I pulled the wire, and I would have a couple of test points here where I could see what the sensor was actually doing, and where I could watch that light to see if the heater was on. That's another little tool I built. Like I don't got that in my toolbox at home. Well, this wasn't a sensor problem, it was a problem with the wiring. Now, how do I know that? How do I know it was a problem with the wiring when my light didn't light up?
It's supposed to be shrinking power to the
See, somebody had already pulled a code and popped the sensor on it, and the sensor didn't fix it, and so they just put it away. So if there's no power going to the sensor, you know there's no wiring problem. What do you do next? I mean, you're basically got two wires hooked to your light bulb. What do you need to know?
trace the wires, see where the power failure is.
Well, you need to know what's missing.
I took you could on the mount,
On what out?
on the wires out.
Yeah, I want to do something easier.
Check and see what power.
Check the test light and see if you got power on the ground.
That's right. You want to see if you got ground on one side, power on the other. Which one am I missing? Because when I find out which one I'm missing, it's going to tell me which way to go. Right? Okay, so here we got this. So you pulled up the schematic, and I verified each oxygen sensor circuit is powered by the EEC power relay. So the EEC power relay on these Fords here likes to power up everything that the engine controller works. So since the engine controller controls the oxygen sensor heater, the EEC power relay is going to power up that side of the oxygen sensor, the red wire side, and then it's going to go and deliver some ground to the other side. At least one wire feed each sensor should have 12 volts, and it was there. So I had that 12 volts there. So another test light check looking for ground provided the engine. It was the ground that was lacking, and this one was fed by PCM pin 94. All right, and there's pin 94. And there's pin 94 right there. So you got your, see, that's right here. When you see that right there, that's a heater, guys. See that? This typically indicates a variable signal, although it's not really an accurate use of that, but they use it on oxygen sensors a lot of the time. Notice there's a connector up there too, so on and so forth. All right, so that particular one, pin 94, is actually going to go from here to right there on that oxygen sensor connector, right? So we basically know that we're going from here to here. All right, so I grabbed the breakout box. You guys have used the breakout box we got here before. Now, disconnected the PCM and connected Bob to the harness and leave the PCM disconnected. That isolates the harness from the PCM to prevent bogus readings. If you're doing ohm readings or stuff and you got your PCM plugged in, or even if you got your battery hooked up, you're liable to get screwed up readings that are going to confuse you. So leave the PCM out of the circuit when you're checking the wire harness. That's the smart way to do it. With a test light connected to Bob pin 94, homemade O2 tool installed. In other words, I had my bulb tool installed while I had the breakout box on there. With the PCM out of the loop, the test light should have winked off when the bulb was removed, because removing the bulb removed half the power coming from the O2 heater. It didn't. So I decided to connect the PCM to it just to see if it would decide to ground the heater control circuit, and it didn't. So this is basically what I did. The oxygen sensor looked like this before I took it out of there. My tool's here, my light right here, just got it hooked up right there. So power coming in here, basically going to the PCM. I got the PCM disconnected, right? All right, so I got a test light up here. This is hooked up to the breakout box. The breakout box will be here. And so basically, I got a light right there, but this one wasn't lighting up. Okay, now this bulb right here is going to be stronger than that one, so the test light's going to light without lighting that bulb. That bulb turns into a piece of wire. So, with my homemade tool removed, the test light bulb should have gone out, but it didn't. Pull that out, this stayed on. Got it? All right. pull the bulb out, stayed on. That's what happened there. So I left the PCM connected, rechecking the pin assignments. I found the pin 93 leading to the oxygen sensor 1 and 95 feeding the only sensor that was on the backside, which only had one catalytic converter on it. And since the downstream sensor connector was easier to access than the one for the other one, I moved the pin 95, and I had 90 disconnected downstream sensor, and the test light winked out. Okay, so the HO2S12 circuit was working properly. Somewhat. All right, so let me shoot that. See, that's where I had it disconnected. All right, so what I figured out here, with the test light probe resting in Bob pin 93, I worried the connector loose while he watched the light. It winked out, but now we found out pin 94 went dark too. So it appeared the wires leading to pins 93 and 94 were shorted together somewhere. Basically, there's those two pins. They're touching each other because they both are fired up at the same time, you know, when they're supposed to be discrete. All right, so this connector right here, see how important it is to be able to find that connector and find out where it is and all that. It's kind of funny, one time I had these numbers all memorized. The 12A581 harness is the one that goes to all of the computer stuff on the engine, and the 9D930 harness is the one that plugs into that. So on one side of this connector is the 9D930 harness, on the other side is the 12A581 harness. The shop foreman didn't have those numbers memorized, but I had got my head so deep into the wiring where I just would rattle those numbers off without thinking about them. I was working on a motorhome that was giving some kind of a problem. I can't remember what the problem was. And I found a problem right here in this connector, and I fixed it. And he drove it, and he said it was okay. And he says, "What did you find wrong on that?" And I says, "Well, you know that big connector in the front where the 9930 and 12A581 wire harnesses go together?" Well, that just sort of boggled his mind because he didn't know what those numbers, you know, he didn't have those memorized, and he called me a smart for that, you know. But anyway, I wasn't trying to be. I was just trying to tell him what came out of my head, you know. Most Ford pickups since '92, though, have had that big connector. It marries the 12A581 to the 9930. I disconnected that, found a common point. See, that's a common point. They're both passing through that same connector. Well, the power vanished from 94 when that was disconnected, but we backfed 12 volts into the EVR solenoid power terminal so we could get some juice to those sensors. And since the breakout box was out of the loop with the C101 connected, we researched the pin out and checked the circuits with the female side. And see, we disconnected it right there. I've basically shown it being disconnected. And with it backfeed, we checked each sensor, the circuit side of the connector, and what we tracked down when each of the sensors was unplugged, the test lamp was extinguished, pointed us away from the engine harness and toward the PCM. We figured out, in the long and the short of it, we isolated the harness. We figured out the problem wasn't on the engine side of the harness. We didn't have wires shorted together over there. We had some on the PCM side. Well, between the PCM, and see, there we are doing our test at that connector. You know, we found out which pin that was and all that. And we fed power into that EVR to give us power down there so we could do our testing. All right, so we found the location of the short circuit. With this disconnected and the short circuit between pins 93 and 94 disappeared. That isolated the problem to a few inches of wire between the male side of that big connector and the PCM. And with that still disconnected but the breakout box plugged in, we measured a 2.6 ohm short between 93 and 94. When we disconnected the PCM, it caused the short circuit to go away. And this F-150 would need a $280 PCM. But what we didn't do was we didn't just say, let's throw a PCM at it and see what that does. Because a lot of people do that. Then when they don't fix it, they say, well, it needed that, but it needed this other thing. You know, whatever. You know, you can come up with any kind of a story. One time, long years ago, back in the late 80s, I got a call from a little small Ford dealership down in Florida. And they had a brand new Ford Aerostar that wouldn't start, sitting in the shop. And they couldn't figure out what was wrong with it. Their mechanics had run out of ideas, and it was, the people had just bought it, and you know, it wouldn't run, they were mad. So he said, I'll make it worth your while if you'll come down here and help me figure out what's wrong with it. So I told the service manager I was leaving and went off down there to help them out with it. When I walked in there, I was wearing my Ford uniform and all. They acted real ugly because they thought I was in there looking for a job, I guess. I don't know. Well, when I went over there, he said, this guy's going to see if he can help us with this. They said, they've already put a distributor in it and all this, and they can't get no spark. And so I went over there and I pulled the spout connector, the spark output connector you pull to set the timing. And when I pulled that, it fired up. You know, it took about 30 seconds to get it fired up. And they ran over and wanted to know what I found. And I said, well, I unplugged the spout connector. If it shorted the power or ground, you don't have any spark. You know, so that's the first thing the book tells you to do is unplug the spout connector and see if you can spark it. It's not complicated. So what we did was on that one, we did the same thing. We tracked it back to the PCM. The PCM was shorted internally, you know, electronics. So we went up front, and the lady up front that was always looking at the part was always jerking them boys around. She said, I need the number off the old part. And I saw this Essence book laying over there that they put out there for the mechanics. It's got pictures of decals in it and all the part numbers and all. And I said, you don't need a piece. Give me that book right there. So give me that book. So she handed me the book, and I flipped it open. I said, there's the part number you need right there. You know. But see, she wouldn't let the mechanics have that book. She kept it back in there, and she didn't know how to use it. But you know, a lot of times if they don't have a whole lot of volume going through there, there's a lot of stuff that the bigger dealers will know that the littler dealers won't know and all that kind of thing. But so the PCM detected the short and knew enough to shut all the heater circuits down. Well, it only showed a fault at sensor 2.1. It was throwing codes for every O2 heater on the truck, right? And since the heaters were shut down, the sensors were largely unresponsive unless a long test drive was underway. So the long drive, the exhaust system would heat the sensors up to the point the fuel trims looked good. Then the used car department guy's test drive somehow satisfied the drive cycle criteria. It needed to re-illuminate the mill. The original 1.1 sensor had been replaced early on, but it's, not misspelled on, but its internal heater may have been shorted, which could have caused the destruction of the PCM's internal circuit. So if the PCM, you know, if you had a wire harness, or I mean a PCM internal short that basically fed power in there where it was also trying to feed out of ground, that would fry that driver. You know what I mean? So that's where you put power where ground's coming out of a piece of electronics, there's going to be smoke. All right. Questions, comments? What did you learn? How much of a nap did you take?
What?
Yeah, how much of a nap did you take? Did you take a nap? All right, then.
PCM for a vehicle costs $280.
Yeah, that one did at the time. You can get one cheaper than that now if you buy one that's, you know, rebuilt from the parts house somehow. But,
Probably for that.